computer programs, we use something called a variable to store a data type for the lifetime of its requirements within that program. So data types and variables go hand in hand, and we will also be introduced to functions, and functions can take in variables as parameters and return values as variables once they're completed. So variables are data items which can change, hence the name variable, and they must be defined in most programming languages, but not all. We'll come on to that later, to state what type of data it will hold. In Visual Basic, this is called dimensioning a variable. And what this does, this means sizing the variable in terms of the number of bytes that it requires of RAM in which to store its value. So dimensioning, or a dimension is a size. So in VB, when we dimension a variable, what we are doing is giving instruction to the compiler to reserve a certain number of bytes in memory in which to store the bits that represent that particular variable and its value. So we use the keyword dim in Visual Basic, DIM, before the variable name. So dim I miles as integer. Some useful things to point out here. We can call variables anything we want. Generally the rules are it must be alphanumeric characters. It can't start with a number, otherwise the computer would generally think that that was an actual value. And you can't have spaces. It's not good practice to put things like dashes in there because they will be taken or interpreted as maybe a minus sign perhaps. So a common method is to use something called camel case, and when I write use variables, I usually prefix the variable with a letter that represents the type of data. So in this case, the I tells me as a programmer, doesn't tell the compiler, but it tells me as a programmer that this variable is an integer, and then I capitalise the first letter of the actual variable name. So in this case, it's I miles. So I can see as a programmer that the I means to me an integer. However, the compiler doesn't understand that, so we tell it specifically that this variable should be dimensioned as an integer value. This one is another variable, and it's of type single, so it's a single accuracy floating point value. And you can see here how the camel case is working to capitalise the first letter of the individual words, if you like, that make up that particular variable name. So dim dimension S temp in Celsius as single. So we could, as a programmer reading this program, we could understand that that variable is likely to be storing a decimal value that represents a temperature in Celsius. So naming variables is very important to programmers to understand the context of that variable, what it might be used for in the program, and also in some cases the type of data that that particular variable is storing. This is a third example, and this is a character value, and I mentioned on the previous slide that character values in the past have been 1 byte, but more normally these days they are 2 bytes in length, and this variable is going to store presumably a character that is entered via the keyboard. When it comes to using variables with functions, functions perform a function and they return generally a value once they have completed. And so what we have to do is, when we declare a function in a programming language, is tell the compiler what type of data that function will be returning, whether it's an integer, whether it's a single, whether it's a character or a string or whatever. But we'll come on to functions in later sessions. This is an example of a function. We can guess that this function is one that calculates a square root. It takes in one parameter, takes in a variable x as a double, and it returns a double value. But as I say, we'll come on to functions later on in other sessions. So variables can only actually hold one value at any one point in time, but over the lifetime of a program executing in computer memory, that value can actually change, and it can change any number of times. So the value is variable but at any one point in time it has one and one only value. Now, most programming languages are what's called strongly typed, and on the previous slide I was saying how we tell Visual Basic what type of data a variable is using by the use of the dimension or the dim keyword. So strongly typed languages force you to declare your variables before they are actually used, and languages or traditional programming languages that are compiled, so things like C, C++, Java, are strongly typed. There are, however, many weakly typed languages out there, and typically these are maybe scripting languages like JavaScript, PHP, VB script, things like that. But Visual Basic is also capable of being weakly typed, and weakly typed languages allow variables to be created by the compiler or the interpreter. I'll come on to an interpreter in a minute, when they are first encountered, and generally the first usage of the variable where it is assigned a value then determines what type of data that variable will store. And this can lead to mistakes, so it's not generally a good idea to rely on weakly typed languages. They do introduce several problems. So Visual Basic can be used in the same way as a weakly typed scripting language, but it can mean that simple typing mistakes are often treated as two different variables. So this bit of code here, we can see that the first line dimensions a variable called text1 of type string, and then presumably the programmer in the following line was going to be assigning the value hello in quotes, look, it's a string literal, to this variable. However, notice that there are two spelling mistakes between that variable and this variable. The T and the X are transposed, but also it's a capital T, and different languages will treat that in different ways, but because of this spelling mistake, then these are in fact two separate variables. The compiler can't make a decision itself and think, the programmer's made a typing mistake, so therefore I'll assign this value to that variable. These are two distinct variables. So later on in the program, when you want to make use of text1, you might find that it actually has no value, even though you think as a programmer that you've actually assigned it a value. These sorts of mistakes can be very, very difficult to spot when you are trying to debug a program, because you inherently sort of believe that you've made no typing mistakes when you've written a program, but usually you do. So strongly typed programming languages would pick this up, and this would be a syntax error. The programming language or the compiler would report that it doesn't know what tetx1 is, and this would then alert you as the programmer to rectify that problem very early on. So it's very useful if you are programming in VB to actually turn this feature off, and you can do that by finding the option explicit value, which will be associated with a project in .NET or in VB, and you can force that to be on, which means you have to explicitly declare your variables before they are used. So that is a very useful thing to be doing. It can significantly reduce the number of errors and the time taken to find those errors. So let's now have a look at some simple programs that make use of variables.